So let's look at a couple of problems where we don't have a graph in front of us. So these are pretty common problems. In fact, I think we've solved them in class this year. I'm being asked to find the limit as x approaches -5 of 2x minus x squared. This is going to be a case where our first thought is let's plug in the number. Let's plug it in, the it being this -5. Everywhere we have an x over here, we're going to evaluate this function at -5. 2 times -5 minus -5 squared. 2 times -5 is -10 minus -5 squared. We get -35 as our answer. So we would state that the limit as x approaches -5 of 2x minus x squared is equal to -35. Nice, easy limit question. You get to plug it in, and the answer that you get by plugging in or evaluating the function at that point is indeed the limit. Let's look at the second one. The second one, we're being asked to find the limit as x approaches 2 from the right of the square root of 4 minus x squared. If all we know about limits is we plug in the number, well, sadly, we're going to get the wrong answer. Because the student who just plugs in the number here will say, all right, 4 minus 2 squared, that is the square root of 4 minus 4, that's the square root of 0, and that's 0. We need to be careful here. The limit that you're being asked to find is the limit as x approaches 2 from the right. That means numbers that are greater than 2. How much greater? Just a little bit greater. Think 2.0001. Well, if x is bigger than 2, even just a little bit bigger than 2, x squared will be bigger than 4. Positive 4 minus a number bigger than 4 will give me a negative number. And we do not take the square root of negative numbers in calculus. We're not going to worry about imaginary numbers. For what we know about calculus right now, we don't deal with that. So I would say that the limit as x approaches 2 from the right of the square root of 4 minus x squared does not exist. And I would say because if x is greater than 2, because x greater than 2 is not in the domain of the square root of 4 minus x squared. Okay? So, let's go to this last one. We have the limit as x approaches 2 from the left of the square root of 4 minus x squared. Here we want to be thinking about small numbers. Numbers that are smaller than 2. Just a little bit smaller than 2. For example, 1.9999. If I evaluate this function at a number just smaller than 2, a number just smaller than 2 gets squared, well, that means it's just smaller than 4. Positive 4 minus something smaller than positive 4 will be very close to 0, but it'll be greater than 0, and the square root of that will be very close to 0. Let's go through that and do some better notation. What we said is x is approaching 2 from the left. As x approaches 2 from the left, x squared gets closer to 4, but it is smaller than 4. We are to the left of 4. 4 minus x squared is going to get closer to 0, but we are going to be just a little bit bigger than 0. Which means that the square root of 4 minus x squared will be very close to 0. It'll be just a little bit bigger than 0. But as x gets closer to 2 from the left, and x squared gets closer to 4 from the left, and 4 minus x squared gets closer to 0 from the right, we get closer to 0. The square root gets even closer to 0. So the limit as x approaches 2 from the left of the square root of 4 minus x squared is equal to 0. Done. These last two are very different questions that you definitely want to pay attention to on the unit exam. You always want to pay attention to your domain restrictions. Don't just go ahead and blindly plug numbers into the function. Take your time. Make sure you're not causing any domain problems.